Hi, everyone. Today was my first day of classes in person at Wake Forest University for my master's in math. We covered, let me talk about what classes I was in. I was in Intro to Math Modeling, and then a thesis meeting with Dr. Sarah Rayner, who is awesome. And then I was in I was in Graduate Real Analysis with Dr. Miaohua Zhang. So starting off with math modeling, that's a discrete dynamical systems and continuous dynamical systems applied class. We cover differential equation models, epidemiology models, chaotic systems, bifurcation diagrams, stochastic matrices, stochastic models, things like that. I think that class is going to be kind of easy. They don't expect prior knowledge in the field, so we started off today with an SIR model of white nose fungus in bats, which is an incredibly deadly disease for bats. So perfect to describe SIR modeling to a bunch of people who don't know what it is. For those of you who are watching who don't know what SIR modeling is, it's a compartmental model of disease with susceptible, infected, and recovered, where recovered, that's the most simple version of it. It can have death, it can have birth, it can have quarantine, it can have erratic behaviors added in. So there's a broad swath of extensions of the problem. And so that was the first day of class. We covered that. That's a undergrad and grad cross-listed class, but the people in the class are all seniors, so we just introduced ourselves to each other and then started working. And that's going to have like a bunch of MATLAB projects. I might actually use Python or R or something just so that I have more for a job. Then my thesis meeting with Dr. Rayner, we discussed my thesis, obviously. We had decided on a problem a couple weeks ago. So today we talked about like what my goals should be for the problem and then how to extend it to a larger class of problems. I don't want to give it away too much because it's a relatively simple problem and I think somebody might be able to just take it if they find out that it's unsolved. But if you know me, talk to me in person and we can talk about it. Lastly, I had real analysis 712. And so this is actually important. The structure of real analysis at this school is that most grad students start at 611, which is the same as undergraduate real analysis, cross-listed, but they take it as a refresher course basically, and then move into 711 and then 712, which are like baby functional analysis / real analysis. And then 712, that's 711, 712 is integration and measure theory. So just if you're worried about grad school, there are usually basically, at least in the master's I'm in, half or more of the incoming students are in the introductory abstract algebra class, and the other half or more are in the the introductory real analysis class, which are the undergraduate classes. They're just taking them at a slightly higher difficulty than the undergrad version. So if you've already taken those in your undergrad, your life will be very easy. Unless you're like me and you decide to go for the higher classes. So that's not to say that they won't be easy, but they're not as easy as taking the refresher courses. That may be different at some higher level schools. I'm sure that if you go to Duke or MIT, they just throw you in the deep end with the 700, 800 level classes, but that's how it is here. The 712 class today, we started off with 4 equivalent sorry, not equivalent. We started off with 4 definitions of Riemann integrability, 3 of which are directly equivalent, and one of them is a weaker case because it requires stronger conditions. So the Riemann integration that you learn in calculus textbooks, where you use equipartitions of the space or of the set that's defined over the support, whatever you want to call it. That equipartition is a very strong condition because you can have behavior of the function that is maybe less well represented by an equipartition and is better represented by a generalized partition. We always use finite partitions as well, to be really clear. That's a problem that comes up a lot. So we want to find the supremum of the lower sum and the infimum of the upper sum, and those need to be equal. So the upper and the lower Darboux sum need to be equal. That's the condition for Riemann integrability. Equivalently, you can create a limit definition with an epsilon delta formulation for the partitions. That works as well. If it doesn't satisfy the partition definition, it can't satisfy the Darboux definition. So that's the first day of grad real analysis. We started talking about interesting functions that are Riemann integrable but are discontinuous at countably and uncountably infinitely many points. That's really cool. I was surprised. Yeah, Wake Forest campus is nice. I went on a hike through the cross-country trails. They go around like the southeastern side of the campus, and they're quite long. So, and they're out in the woods. So I just nice place to go walk around, away from the cars, away from the heat. Yeah, I guess that's it. At least getting to know my cohort. There are about 40 of us. I think I talked about this before. About 20 new students. Of those, there's maybe 2 or 3 of us who are first years who are in the 700 level classes, which is surprising. And then the last thing that I think I should talk about is the accessibility and availability of the faculty. Once you're a grad student, I don't know what has changed, but the faculty are like very willing to talk to you in a way that the undergrads are, they don't have access to professors in this way, or they don't want to. But the grad students and the professors sort of interact not quite as equals, but much more than the undergrads and the professors. So use that, because I've already used it. I've already used my access to professors to help me with problems for my thesis from the study that I'm doing with Evans, PDE, etc. So that is a very useful thing to do, just to have faculty friends. I can say friends, right?